who's going to tell us all about generative systems in assistant artists. So if we give him a round of applause.
Hi, my name is Guido Salimbeni. Today I'm presenting in the next 10 minutes the work I've done for my first year as a PhD student at Goldsmiths University in the Department of Computational Art. And the talk is about this paper that is being accepted for the NeoRIPS workshop 2019, which I co-authored with Professor Frédéric Lemarie and Professor William Layton. So my background, I'm an artist, and here I'm showing what is the two main steps that a painter goes when he decides or she decides to paint a still life painting. The first step is about choosing some object and try to arrange this object on a supporting painting table. Here we have vase and some fruits, and then while the painter is trying to arrange those elements on the pictorial plane, she's looking on specific principle of design and also some aesthetic evaluation. And once she's happy, she will start the process of the execution of the painting. So my motivation was, can I somehow use some machine learning solution to automate the first part of the painting process? So to find the optimal arrangement of object that I will then paint in an actual canvas, on an actual canvas. And the other motivation was, what's the difference between using the system that I will describe to you against a generative adversarial network? And lastly, my idea was that if I can apply this principle, this system, in the specific area of painting, I can translate the same idea to the media and design industry. Here we have Giorgio Morandi at work. He's a painter that I choose as my benchmark, I would say. He's an Italian painter born in Bologna in 1980, where he dies in 1964, and 1819, sorry. And here is looking at some potential items that he wants to paint. And on the right there is the final painting, where I overlaid some lines to describe to you some potential principle of design that the painter must have looked at when he decides the composition. One very simple things you would like to look at is the balance, that things on the area of object on the left will be kind of equal to things on the right. But if you look at this image, you can see that if we apply some very precise mathematical formula to detect this balance, it's slightly unbalanced on the left. So there are more things going on in the painting. And for instance, it's known that line that goes towards the center of the picture will increase the weight of the other part of the painting. So this line, for instance, is increasing somehow the weight of the painting on the left, on the right, on your right. And then there are many other things that you look at. You look at lines that are crossing. Usually crossing lines are detecting your attention more than not crossing line. Parallel line are things that you need to deal with the caution. And moreover, negative space are something that you look at. So the first step was for me to collect many paintings from Giorgio Morandi. As you can see, it's mainly still life painting and ordinary objects like vase, bottle, and boxes. Follow that, being also 3D modeler, I translated all those paintings into 3D object, and I created a data set of 300 samples of good composition. Then, because I'm also a 3D game developer, I decided to use a game engine called Unity 3D. And the idea was to use this game engine and leveraging the features of the game engines to develop a system that can analyze both the rendered image on the screen plus other information that I can extract from the engine, like the position, the depth, and the volume of the object in the scene. On top of that, I also connected the engine with the online database that is updated with any new scores or any new evolution that the system achieves. So how does it work? It uses a genetic algorithm to find the potential optimal solution for the composition. It's a combinatorial problem where we have some constraints, and the inputs that I decided to use were three types of inputs. One is the front and top camera view, because working in a 3D environment, I can play whatever I wanted. So I decided to place a camera on top and one on the front. And my idea was to use that information as a solution to depict information on the painting, translational invariance. So I wanted that instead of using a convolutional neural network, I opted for an artificial neural network. So the position of the pixel in the image will count as they are in that specific position. But I wasn't interested in that specifically for the painter point of view. So I used a convolutional neural network to extract data from the painter point of view. And finally, because I was working with Unity, I can develop my own crafted computer vision feature extraction using OpenCV. And I developed 4 algorithms with OpenCV. One was to detect symmetry, a symmetry score, and another one for the unity score, how close the things were together, and another how much they are separated, isolation score, and finally a balance score. Those inputs goes through the networks that then combine into one single output, and that output feed into the fitness value of the genetic algorithm. So through the usual genetic algorithm approach, we have an initial population, is a fitness calculation, and then if the loop is finished, then we got the results. Otherwise, we go again through the loops. And then I compare the result of of this system with a generative model. Here we have a sample generated by a DC GAN, working on the original 300 sample data set. And when I look at those images, I felt like very pleased. I mean, I think I was, if the goal is to find a potential solution for a painting, I would say there is a lot of inspiration here that can be used for a new painting. Then I output some samples for the system from the system, and I kind of look at the difference between the two systems, and the next slide I'll show you my conclusion. So my understanding was that in the system that I created, somehow the machine learned to not intersect objects one each other. The same things were a bit more difficult to spot in the generative adversarial solution. Another thing is that because the system looks at things from the top, is aware of the position and the depth of the position of the object, whereas the same things is a little bit more hard to depict in the samples produced by the GAN. And maybe one of the things I noticed more was that because in the samples there were any rotation of object, the GAN I don't think is able to rotate an object if there is no sample of that object rotated in the original data set, whereas a genetic model is trained to do so by definition. obviously, the DC GAN is way more quickly. Obviously, produce a result much quicker. But by using a genetic model, I was able to introduce new item on the way. I mean, I can, yes, I can select more than the items presented in the original data set. I can change items, things that the generative model is not able to do unless those samples are already provided in the original data set. So in conclusion, this is the entire pipeline. There is some samples that a painter would select. Then, based on the architecture and after a few generations of the genetic algorithm, he will produce some more samples. The painter will choose one of them, and he will execute the final painting. So the genetic algorithm can produce new images that also account of rotation, difference in depth, and difference in items. In my mind, this is the first step. Like I built a framework where I have the ability to introduce new inputs. At the moment, the inputs are input handcrafted using OpenCV and different camera point of view, but these things can be eventually integrated with other kind of source, maybe streaming data from online, or maybe Instagram, look at other painters or whatever. And yes, the next task for me would be to do the online deployment, which is, as a first year PhD students, I found that one thing is developing the prototype. The other thing is the deployment of the things, especially machine learning, and transfer the entire system online. I found it quite challenging in terms of size of the network, size of the weights, and the fact that if you want to run the same things on the browser, things can get a bit more complicated. But this is the end of my talk.